Okay, now welcome back. So we're going to do an example. This is the first of two examples that we're going to do. And what we want to do is we want to find the second derivative. I think that's what they want us to find. They want us to find f double prime of x. Okay? So they want us to find the second derivative of x. Okay, so the way we have to do this is we have to do this by putting the function through the limit process twice. Okay, so I'll show you what I mean. So the first thing is we're going to take the limit as x approaches, or excuse me, h. As h approaches 0 of what? f of x plus h minus f of x over h. So now let's do that. So we're going to get the limit as, keep putting x, h approaches 0. Now we're going to have 2 times x plus h squared minus 3 times x plus h plus 1 minus the whole thing. 2x squared minus 3x plus 1 over h. Now, what's going to happen again is things are going to cancel out, and you'll be able to factor out an h and cancel the h in the bottom. So this is going to equal the limit as h approaches 0. Okay, so what do we get? We get 2x squared plus 4hx plus 2h squared minus 3x minus 3h minus 2x squared plus 3x minus 1 over h. Now, we have a 2x squared here minus a 2x squared here. Those are going to cancel. Everything that just has an x should cancel. Well, not everything. Well, anything with just an x should cancel. So we've got minus 3x here, plus 3x there. And now, we simplify. So now this is going to be equal to the limit as h approaches 0. And what do we get? We get anything. Okay, so we get 4h oh, hold on. We missed one. I knew that I was going to see something. 3h plus 1. I forgot the 1 here. Okay, so plus 1 minus 1. So those should cancel. Okay. So see, I knew something was wrong because I saw that I wasn't going to be able to factor an h out. So I knew I was missing something. So 4hx plus 2h squared minus 3h over h. And so now this equals the limit as h approaches 0 of h times 4x minus 3 plus 2h over h. And the h's cancel. And now we get the limit as h approaches 0 of 4x minus 3 plus 2h, which equals 4x minus 3. Okay, now, this is our first derivative function. Okay, so we just found f prime of x. Okay, now, so we found f prime of x is equal to 4x minus 3. Okay, so now to find the second derivative, we're going to do it again. But we're going to use this function. So we're going to do the limiting process on this function. So the limit as h approaches 0, now it's going to be f prime of x plus h minus f prime of x over h. Okay, now let's start the process again. Okay, so now this is going to be 4 times x plus h minus 3 minus 4x minus 3 over h. And so now it equals the limit as h approaches 0 of 4x plus 4h minus 3 minus 4x plus 3 over h. And so now 4x minus 4x minus 3 plus 3, and we end up with the limit as h approaches 0 of 4h over h, which equals the limit as h approaches 0 of 4, which equals 4. So the second derivative, f double prime of x, is 4. So now what does this mean? Well, remember, the first derivative gives you the change in the function. So it's a slope function. It tells you how the slope is changing, or how fast, let me say that again. The first derivative, we call it the slope function because it tells you the slope, what the slope is at every point in the domain, right? The second derivative tells you how fast is the slope changing, right? Think about it in this way. The first derivative tells you how x is changing, okay? So change in y over change in x. So it's telling you the slope, right? The second derivative is telling you how the slope is changing. So if we talk about, in the case of position function, when we're talking about physics, we're talking about a particle moving, well, the first derivative tells you the velocity of the particle, right? It tells you how the position is changing over time. The second derivative of the position function over time is telling you the acceleration. It's telling you how is the velocity changing over time. Okay? In the case of a function, though, in a general function, the function tells you the value of the function at some value of x. The first derivative tells you the slope of the function for every value of x. The second derivative of a function tells you how the slope is changing for each value of x. Okay? That's it. Now we'll do another example.